I hope everyone can hear me. Okay, so my name is Hasan Ali Khattak. Today I will be, you can say that I will be taking the topic which Russell explained, the idea, but we will be seeing the same idea with a different perspective. So the title of the talk is True Disease Classification using resource infinite devices. Mainly, we assume that not all forms have internet access and not all devices should have internet access due to many reasons. Because normally communication takes your, energy load. So we are assuming another aspect of it. So a little detail about me. I am with the Department of Computing at NUST. I did my PhD from Polytechnico di Bari in Italy. It is it is a university in the south of Italy and a very beautiful landscape. My interests are basically data analytics on different, you can say, different domains. During the PhD, I was working on the healthcare informatics, now mostly on the vehicular networks and especially unmanned aerial vehicles. Currently, we have a lab here. We are trying to understand things and we are trying to learn things. So you are most welcome to interact with us. So this is a little about the agenda, but I'm reading this is not useful because you have to in any way. You do not have any option to skip any of this. So let's start with it. So the main concept is that we want to revolutionize the farming, you can say, or agronomy. I would say not farming, but agronomy. That was the whole. So these are a little momentums, baby steps we are making towards intelligent farming or smart farming. So normally, when we say about farming in Pakistan, for example, one of the major contributions toward the GDP is farming. We are a large agriculture country. We did used to export a large chunk of many of the grains, you can say, many of the fruits we used to produce. But we have seen a little incline in the whole due to, you can say, different aspects. So there are many momentums we want to improve this situation or as a whole. So we want to take this momentum a little further. For this study, we have taken apple, fruit apple as a sample, but it can be applied to almost any of the indigenous crops or indigenous fruits and grains we are producing in Pakistan. So I will take cue from Dr. Asad's slides. He presented a very good idea, but there is a restriction for countries such as ours. So there was a slide, I don't know how attentive you were, but there was a slide in which they presented that normally the drones take updates from, you can say, satellite or radio frequency tower. So in that case, not only the drone is keeping itself on, for example, in air, as well as capturing some data, but also it has to communicate. And it has been noticed that the communication part is one of the major, you can say, contributor towards resource constrained device, you can say energy consumption. If you ever see that your devices, laptops or phones, you can monitor it. One of the biggest contributors is that the Wi-Fi or DSL network when it is connected. So we want to minimize this aspect so that drones can do more tasks in the same battery life. So rationale behind this is that due to advancements in as a whole picture, there has been a lot of advancements. The batteries have been improved. The processing power has been improved on the drones. There are many powerful GPU-enabled devices which we can leverage for these problems. Secondly, one of the another rationale can also be that there are areas such as you can say in the northern region of Pakistan, you can say, or the large fields in south of Pakistan, where we would not have access to, you can say, internet. It can be GSM or Wi-Fi. I mean, we do not suppose that the drones will be connected continuously with the satellite because satellite is a very expensive communication mechanism. So taking the cue from this idea, we want to enable classification on device. So this what it does, the only restriction will be that we have to have updated machine learning model on the device. Other than that, normally it will perform its own tasks autonomously. So we did some experiments. Let me give you an idea. when we move forward. So, as I explained, that the motivation behind this work or this attempt is that Pakistan is a agricultural country needs to improve its output or yield. There can be many venues where we can do improvements, such as you can say we can improve the pesticides, we can do improvements in the you can say the things we put in the soil to enrich our plants. But we also need to improve other aspects, such as let's monitor plants and detect diseases very early, so they can be you can say cured or prepared for the diseases which normally the crops have to do this. Traditionally, this work is done by farmers, normally by observing. They do observe their field. It is a tedious task. Imagine hectares and hectares of land, and you have to walk there and you have to analyze it daily. So this is a hectic thing. What we want to do that let's do this job with a drone, which has more accuracy. It does not get tired. It has, you can say, updated models, and it can do more work in limited time. And probably with a swarm of drones, you can analyze the whole field within minutes or within hours. So this is the basic idea. We did some studies that if there is been some work done on resource constraint device as a whole, but the main issue has been that there are actually two main issues in the whole you can say approach. First of them is that there is a limitation that we do not have data sets, enriched data sets trained aspects, these areas. That is, for example, we considered the fruit apple. So for that, we found very limited, you can say, data sets. Maybe an attempt can be made to enrich these things, these data sets. So most of the studies have given very good accuracies, but they have assumed that they are predicting good or bad fruit. But we want to go a little further. We want to detect that if the fruit is bad, what is happening with it, which disease it is, and then we can recommend the farmer with the suitable pesticide, for example. So these are some of the studies. Mainly, they have some limitations which are explained here. But the thing has been that most of them have relied on the detection of disease, not the classification of disease. This is a little thing which you want to contribute. So the problem which we feel that can be addressed is that we want to do two tasks. One task is we want to change the mechanism of how the farmer is seeing his field, hectares and hectares or large areas of field, and we want to do it efficiently. One thing, so drones come in play here. Second, we see that we need to do the classification on device. We do not want that, for example, we go into a field like 20 or 30, you can say, not 20 or 30, but rather like 200 kilometers away from some place. You collect some data, you put the SD card in your device, load the data set, and then do machine learning. You want to do it on the, you can say, remote area. So this is the main goal. So for this purpose, we developed a methodology that we need to, first of all, we need to identify that what kind of diseases there are for apples in our area. This is an attempt, and we are starting towards this. So let's start with classifying at least some of the diseases which are more, you can say, normal in our area in Pakistan. So the data set has been collected for apple in our case. So we try to only identify the disease which we have for the fruit apple. So we have seen that there are like four common diseases which are found in Pakistan in the apples which are sold in Pakistan. So it is blotched apple, then there are rotten apples, then the apple has scabs. These are some of the, you can say, diseases which can be detected by cosmetic, you can say, analyzing of food. So computer vision comes in play here. So in the data set we had, it is not a very rich data set, but we had a sufficient set of, you can say, files. So we divided our training and testing data set into, like, you can say, 20 and 80%, and we trained our model for resource constraint devices. So for this, we have like for the whole experiment, I would like to Like, at that we use TensorFlow Lite because it works on these devices. The devices which we try to you can say evaluate were Android, because normally most of the phones are coming with Android and it is one of the popular operating systems. So the idea was not only drones, but we should also have application which we can give to the farmer. So he can do it himself as well. For example, even for the drones, it cannot capture everything. For example, in case of apple, one has to go near the tree, in the leaves, in the structure of the tree, and then detect it. Then we did experiments that, for example, if the drone is equipped with Raspberry Pi, it is a rather cheaper one, cheaper device. It does not have a GPU, but it can do compute potential efficiently. Then we did experiments on Jetson. It is from NVIDIA, and it is, you can say, on resource constrained devices. It is one of the powerful single board computers. So these are some of the specifications. Most of them are, you can say, battery operated. All of them are rather battery operated. So the parameter which we were testing, that how the machine learning model performs and how much power it is consuming. So what is the effect of power on each of these classifications? So the experiment was run in most of in all of these devices in different scenarios on different workloads, number of images, series of images and videos you can. So the implementation was rather simple. The machine learning model was trained on the data set. It was optimized for resource constrained devices or mobile devices. There are multiple frameworks, but we use TensorFlow Lite for this. Mainly the classification results were, I mean, you can say very varying due to light conditions as well. Because, for example, if you consider, I mean, this is another research aspect which can be looked upon, because when you are acquiring the images, the sunlight and other atmospheric variables are very important in this. For this, we consider that we are taking an ideal condition where light and, you can say, visibility is ideal. I mean, we did take care of this. So these models were compared, and we analyzed them that which type of model we will be using. So this is a set of tools which were used in during this experiment. Main objective was to uh, have a self-sufficient device which can operate on battery and do the classification itself. These are some of the, you can say, results which we did for different data sets, as well as also for the data set as well as different models. So if you can see, if you can see, the models have given very good accuracy on training as well as validation. I mean, it is not perfect, but it is very promising. We can look towards improving it. There are many aspects, as I was saying, that luminosity, visibility, these play into role. So these are some of the results which we acquired. First of all, we used basic CNN model. I mean, to start with the experiment, we used CNN model. Then we try to evolve it, and the main idea was that let's see that what happens when we do some complex tasks. So then the next was with 3 dense layers, the accuracy has improved a little. You can see from I mean, the model accuracy is improving here. So this is, I mean, something very promising. So then we went onwards with another model which is very famous, AlexNet. Here you can also see that we are having a stable and very good. I mean, the results have been very promising and very good. Next, here we analyze all of these models, and we saw that where we can do fine tuning, and we try to improve the model, because once the model is deployed, we assume that, like Asad was saying, that all the air updates are required for updated models. But in our constraint, we are saying that we do not have internet connectivity, so the model has to be accurate. So we did fine tuning, and the results were still promising. The improvements were made to the AlexNet model because it was the most promising one among these. Okay, so we also tried other models, but the issue was with these models was they were taking a lot of battery consumption, and this was, you can say, one of the parameters on which we had to select or drop a model. So uh, resulting from these you can say experiments and results, we developed three applications. Basically, you can say one was an Android application, so it was using the GPU normally built into phones. For this, a normal phone was used, which is most common, you can say, with farmers. We assume that, for example, if the application is developed for general public. So the application normally, the workflow is very normal. You take the picture, the model is already on the device. It classifies that what or whether a disease exists or not, and what type of disease you have. Then you can say the future you can say effort can be to suggest remedies or pesticides or other actions which can be performed after detection of these. And also we are interested to look towards the you can say analyzing the you can say the intensity of disease and suggesting that whether some immediate action needs to be taken or it has to be you can say informed by some authority or some other organization who can try to help you in the administration of some pesticide over the whole field. So this is the main goal. For Android, we saw that the CPU utilization was not much because we are doing simple classification, but the battery on the battery load we saw that no, normally Android phones have a very powerful GPU, so this kind of classification did not have really great impact. So we just saw that a normal classification, for example, a set of 50 images would take up to 5% of the battery. So this is very promising. In case of Android phones, we assume that these devices are normally used once in a while. But when we come towards our, you can say the Raspberry Pi or the Jackson Nano, we assume that the drone will be taking videos and, for example, a series of pictures, you can say, for a long duration of, you can say, for example, a hectare of or a few hectares of land is going to be analyzed. So we will take more consideration towards the battery, you can say battery specification. This was very simple. We did the, I mean, the model was uploaded over the application. Both of them run on Linux. So I mean, it was very simple. The application is a simple application which takes the data from the camera and then analyzes image single. I mean, frame by frame. So now let's come towards the you can say the comparison. So we see that all of these devices have you can say almost similar, but for Jetson Nano you see that classification time is very reduced because it has the capability more capable. Not only its GPU is more powerful, rather, but also it has more you can say CPU and also RAM. For the battery, we see that in case of, for example, in case of Android devices, we see that loading the application and taking an image was taking more battery consumption, and the model classification was not a big issue. But in case of Raspberry Pi and Jackson Nano, we see that very little impact has been for the same set of images. For example, 50 images were classified on all of these devices. So here we see that the results are very promising. And the good thing is the battery consumption of both Raspberry Pi and Jackson Nano are similar. So the another thing which we want to do is that, for example, in such cases, if you look towards that, if the similar concept is provided as a service, so we want to have you can say over the air updates for the machine learning model. So, and also another aspect is, for example, if you want to cover a large area of, you can say, a large area of land with multiple drones. So, we are looking towards in future work. Recently, we have started work on this. That we are trying to analyze and how we can organize by assigning large land to a set of drones, and then they can classify the whole land with collaborative task offloading. So this is something we are looking towards. And then another thing that there are certain devices which are more powerful than Jetson Nano, but the thing is that normally they are heavier, so we are adding more payload, you can say, the drones. And second, normally they are more they consume more energy. So we did not consider, but there are many other possible applications which can be done on these devices. So some of the references, and if you have any questions.
Yeah, I have questions. So you talked about this using Android, Raspberry Pi, and Jetson Nano for classification. Yeah, but I'm not sure about the comparison. How exactly on what basis are you doing the comparison?
Power consumption.
Yeah, power consumption. But the thing is because um, the Android and all the three have different power consumption, like voltage, current usage, and everything, and also um, the capacity to run the model, as in Jetson can run like maybe better model or heavier model than Raspberry Pi. By the way, this Raspberry Pi using model on Raspberry Pi is something new for me. I don't know about this. So so yeah, so how is the comparison now?
So
Like, how would you compare these?
Okay, one thing I forgot to add is Android does not only run on like phones, but there are also other devices, single board computers.
Small embedded PC or something.
Exactly. So there are Android for things. It's called Android. So we assume that we are taking Android into picture because there can be a possibility that Raspberry Pi or another some single board computer can run Android. So first question towards this. Then you said that how we are loading the model on the.
No, not loading, like comparison was the main question.
Yes.
Because then if we even like let's say compare Raspberry Pi with the Jetson Nano, I'm sure there must be the difference in the weight of Jetson Nano and
Yes.
Raspberry Pi, and then if then comes a trade-off between maybe accuracy also, because I don't know how good the classification is done in Raspberry Pi also, and how fast it is. This is also another question.
Exactly. So like we saw where that I mean this is another important factor because like we were saying that Jetson Nano. So normally the Jetson Nano is more heavier because due to it has a heat sink.
Yeah, heat sink.
I mean, mainly one of the reasons is this. So in our case, we did not take this into account because this was a very mild change for a drone. Normally, drones can take up to kgs of weight. This was something like
But in long run, if you are talking in long run, maybe it might affect it. Yeah.
Yes, I mean it can affect, but we were looking towards a solution for this problem that in the areas where we have limited network connectivity and we want to take on-device classification based solution. So how we do? So we have to make some trade-offs. So either we take some load on the device or we have to connect the device. I mean, this can be another study that, for example, a set of experiments can be connected with this load and with connectivity.
Yeah.
So which of these can be better option? So this is a good idea. I hope I was.
Yeah.
I have a point about I think running such experiments on a device like Jetson Nano or Raspberry Pi versus running them on a smartphone, there are different scenarios, but they're complementing the same application. Every power has a smartphone, a relatively powerful smartphone. So in history, we can capture images and do onboard analysis. Okay, and then maybe we upload the results on this server, and then experts who have drones, they can fly over large and do the same experiment. So same thing is being done, but for different purposes.
Like you can say that the initial he can do the initial assessment, and when he finds an anomaly, then he can say that he can ask for a service to analyze the whole area. Because walking to every tree and analyzing every for the fruit is not an ideal scenario. I mean, another thing is that these kind of applications can add to the overall, you can say, giving an overall idea that where the diseases are and how they are spreading. We can have more data analytics over it. For example, if we add geolocation to these analysis, then this is uploaded to our data set.
Yeah.
So we can see that where where the, I mean, the disease, how the disease has progressed and where it is on a very large data dashboard.
Maybe Dr. Hasan agrees. I rather see this as an application where a farmer notices an anomaly in one of his, let's say, apples. He takes an image from a smartphone, uploads results to their system. The system detects XYZ has been detected, and now he's not sure whether a very small scale damage has been done or it's entire field has been affected.
And then the
So now you need drones to come over and
maybe with a better accuracy or something.
okay, yeah.
So thank you for listening. I hope this was beneficial in any way possible. So let's move forward with the other. If you need anything or you have to ask anything, you can just search me and ping me a message.